We'll see. It is my face after all, so we'll see. But yeah, I am going to post this onto YouTube, so I definitely won't. And I'll yeah, avoid singling anyone out and saying embarrassing jokes about them. Let's begin. So today we're going to be learning a purely algebraic method for solving linear systems. So as motivation, just as motivation, can you guys give this one a try? Just one more. Call it warm-up 2.0. Now, full disclosure, I actually have no idea how this one's going to turn out. So let's dive in. Of course, when you guys all become math teachers, improvising is generally not a good idea. But the last time I did this question was 1.5 years ago, and I forget how it turns out. So let's just all find out together. Many of you guys are comfortable graphing a line without jotting down the slope and y-intercept. Some of you guys just might still feel comfortable jotting down the slope or y-intercept. I'm not your dad. You can do what you want. But I'm just going to jot those slope of 2, y-intercept of -7, and then start at -7, up 2/1, moving a little quicker through our graphing linear relation. We've reviewed this a lot. All right, there's that guy. And I've labeled this one line 1. That makes it convenient to label. I'll just put a big 1 there. Did this one work out to a nice point? I don't know. Let me play catch up here. So this second line has a slope of 1/2 and a y-intercept of 2. So up 1/2, up 1/2. Okay, nice. Yeah, another one in the books where we have a nice common intersection point. Whole numbers, easy to read off at 6.5. Now what I want you guys to imagine is, imagine that I was a sucky teacher and I didn't provide you guys a nice grid like this. Hey,
sorry, can I steal a marker?
Yeah, of course, help yourself. We got lots of, we got a rainbow of colors here. Yeah, okay.
Thank you.
So imagine we didn't have a grid. Maybe you're just doing some practice at home. You don't have any grid paper. Again, your teacher isn't as awesome as I am and provides these nice grids for you when we're solving by graphing. What if it wasn't practical to make a sketch? How could we still arrive at that point of intersection of 6.5? I'm going to show you guys right now. This is the key idea. This is the new concept for today, and then the rest is just stuff we've done before and stuff we've reviewed. To solve this kind of linear system, the strategy that we're going to use for today, when we have our 2 lines in slope-intercept form, we are going to do this. We are going to set the equations equal. And we're going to solve for x. I'm going to show you guys what that looks like in just a second. So what we have is we have y equals something, and y equals something else. And I'm just going to share. You guys don't have to copy this down, but you can if you want to. This is a bit of a logic thing. There's kind of a proposition, a theory that says if A is equal to B and A is equal to C, then, well, would you guys agree that B and C have to be equal to each other? Yeah. Right? That's just how logic works. It's the same thing here. Y is equal to one thing, Y is equal to something else. Then we can set those 2 things equal, which we'll do right now, and we'll solve for x. So let's see what this looks like. So step 1, we're going to take our 2 lines, and we're going to set them equal. That looks like this. I'll take what's on the right side of line 1, which is 2x minus 7. And I'm going to set that equal to what's on the right-hand side of line 2, 1/2 x plus 2. That's the thing for today. Would you guys agree? We spent a whole day solving equations like this last week, right? Yeah. We've spent some time reviewing that. Hopefully you moved the needle, got a bit better. So we now have a path forward. Let's solve this equation, keeping in mind what we're solving for is when we solve a linear system, we're looking for a point of intersection. when we solve this equation for x, we're finding out where those lines meet. We're finding the x value where those lines meet. Now, the strategy I've been using with you guys, now some of you guys will say, well, Mr. Smith, 1/2 is a nice decimal. It is in this case, but it's not always going to be. So I'm going to continue with my pattern of clearing the fractions, okay? I see a denominator of 2. I clear the fractions. I multiply everything by 2. And that gives us 4x minus 14. Everything by 2, remember. If you want to draw in your quadruple rainbows all across the sky, you can feel free to do that. 2 times 1/2, 2 times 1 divided by 2 is 1x, and 2 times 2 is 4. And this boils down to, hey, we're solving an equation, the kinds of equations we solved in grade 9. We've had some time to review, to move the needle to get better, and like frankly, we just get more practice now because this is the skill we need for today. So everybody came from our different grade 9 teachers for the most part, different strategies. My strategy is to collect the x's on the left. So I'll group them together, subtracting x from both sides. We get 3x minus 14 is equal to 4. And now it's a 2-step equation. We'll solve that 2-step equation. And I sure hope we get the same x value we got by graphing. Otherwise, I don't know what we'll do. I suppose I'll just quit teaching. I'll just walk out right now. It'll work. Of course it'll work.
Can you also use this method to confirm your graph answer?
Yep. Yeah, absolutely. Yeah, I guess the idea being you guys who have aspirations of going on to, and 4 plus 4 is 14, you know, and 3U, 4U, like making a rough sketch of things is fine, but it's not always going to be practical or the quickest thing to, you know, make a sketch and draw things out. So look at us. So we have actually verified our point of intersection happens at x equals 6. And we got that by setting the equations equal and using our solving equation skills. Now, the point of intersection, that's half the point of intersection. We still need to find the y value of the point of intersection. We don't need to resolve a complex equation. You guys know how to find y values. We did this the first day, second day, relations, rule of 4. You want to find a y value, given a certain x value, you use the rule and you plug it in. So we think x is equal to 6. So I'm going to substitute x equals 1. Now I'm going to pick equation 1. I'm going to put equation 1 like that in a circle. Why did I choose equation 1? I look at equation 1, and to me that looks easy to work with. An equation with fractions, possibly not so easy to work with. But I'm not your dad. Do what you want. You can pick whatever one you'd like. So let's sub x equals 1 in equation 1 and find the y value. Why did I say x equals 1? We're subbing x is equal to 6, right? That's the value we found. Please forgive me. Yeah, so we think x is 6. What's the y value when x is equal to 6? Doesn't take a lot of work to show. We're going to do 2 times 6, plugging x into equation 1, and then subtracting 7. We should get 5. Last time I checked, that 12 minus 7 was equal to 5. Look at us, guys. No graph required. We solved our first linear system using algebra. I might just make a little concluding statement here. The POI, point of intersection, is the point 6, 5. X equals 6, y equals 5. We can solve by graphing. When the lines are easy to sketch and your awesome teacher provides a nice grid where we can easily read off that point of intersection. But we now also have a way we can do it using algebra. And we do need these methods because, well, I'm going to show you guys why. Can you guys humor me and try to solve this linear system by graphing on the grid I provided for you guys? Make an attempt. We'll just give it the old college try here. So m is, the slope is minus 3 or minus 3 over 1. The y-intercept is 4. So up 3 over 1. Down and down. So that looks like all the points I can get on this grid that I've provided. Connect those to the straight line. So there's my line 1. Okay, no big deal. And then I'll graph my second line. And yes, question? Did I do that wrong? Oh, it's -3. Thank you. Okay, so good talking point. Observe, guys. I am not breaking down in tears. I am only moderately embarrassed, but everything's fine. In math, we make mistakes sometimes. So, you know, I cried myself to sleep last night for an unrelated reason to math, and same thing tonight. If I cry myself to sleep, it won't be because of this. Yes, down 3. Thank you, guys. I appreciate you guys. What would I do without you? Maybe this is why we need a strategy other than graphing, because Mr. Smith makes all kinds of mistakes when he tries to graph. All right. There we go. And if I play catch up with my second graph here, so that is a slope of -1 or -1/1 and a y-intercept of -8. Now, before you guys get mad at me, like -8 is just off there. We can just go one more tick down. -8 can be right here. Everything's okay. All right. We'll use the power of imagination. Our slope is -1 though, so it'd be like right 1 or down 1, right 1. But I can't go backwards. But that line would look like this. So at least now we've graphed our 2 lines. We've made no mistakes. Now I think many of you guys are intelligent and can see, well, you guys are all intelligent, but I think many of you guys can visualize these 2 lines are going to meet, but they're going to meet somewhere off of our graph. Would you guys agree? They're going to converge somewhere, but I didn't make my graph big enough. We don't, but there still is going to be a point of intersection. Fortunately, we now have a method where we can find where they meet without relying on a graph. Yes? Okay. So let's give it a try. Let's apply our new technique here. Let's take equation 1. Let's take equation 2. And let's set the 2 equations equal to each other. So just on the back, I might say this. We're setting equation 1 equal equation 2. But yeah, just take those 2 right-hand sides and set them equal. So -3x plus 4 is equal to -x minus 8. And let's algebraically find out where these 2 lines meet using our skills from our review from last week. So I'm going to go about my systematic way of doing things. I usually will move my variable terms to the left. So since I'm subtracting x on the right, I will add it on both sides. We'll get -2x. This isn't the only way to do it, but I'm just, you know, I go at things systematically. And we have a little teeny tiny 2-step equation. And let's solve for x, and let's see if it's kind of consistent with what our graph is showing us. I'll subtract 4 from each side. Same process every time, which is great because many of you guys like, hey, I like an algorithm. You tell me what to do, and I will do it. Well, this is that, guys. It's you set the equations equal, and you solve for x. So -8 take away 4 is -12. And when you divide both sides by -2, I'm getting 6. Now, I could ask you guys if you guys got the same thing, but I actually have a graph I made. I can kind of see, hey, does x equal 6 kind of make sense? It looks like these 2 guys meeting at x equals 6. I think that's in the realm of possibility. Let's find the y value and see even further if our graph makes sense. Let's sub our x value. So the point of intersection will be when x equals 6. So we're going to sub x equals 6 into, if you've already done equation 1, no big deal. I'm just going to mix it up. I'm going to sub into equation 2 just to be different. For you guys, it doesn't matter which one you plug in. My advice to you guys is to pick the one that you find comfortable working with. So our second equation is y equals negative x minus 8. So take the negative of x and then subtract 8. So the negative of 6 and then subtract 8. So basically, guys, it's negative 6, subtract 8. It's negative 6 outside. It drops 8 degrees. We are at negative 14. And if you plugged it into the first equation, you should have got negative 14 as well. So look at us, guys. We actually have solved our first linear system that we couldn't solve easily by graphing. We now know the point of intersection is 6, negative 14. Now again, since I had a graph, it's worth looking at the graph and just checking out. I think 6 minus 14 seems like a reasonable spot where they could meet. So I'm kind of reasonably sure I did things correctly. All right, guys, 2 in the books. We can do it. It's the same strategy every time. You set the equations equal, you solve for x, and then you can get the y value just by using one of the relations, one of the rules. Anything you guys want to chat about? Okay, let's do one more. Now I do want to show you guys, here's one more case about why we need this new method. If you haven't yet, can you try sketching these 2 lines? Let's try solving this one by graphing. So 1/2 x plus 4. So I'm starting at 4. Up 1, right 2, up 1, right 2, up 1, right 2. Fill my graph up. Moving a little quicker through our sketching linear relations. There's line 1. All right. And let's try giving line 2 a sketch. You know what, I have the space here, so I think I might just list my slope and y-intercept. I think some of you guys would benefit from just doing that, just jotting down the slope and y-intercept. So this guy would have a slope of up 5 over 2, and a y-intercept of minus 5. All right. So we'll start at negative 5, and then up 5, right 2. Up 5, right 2, I came close to that common point, but did you guys get like you're just 1 under that point plotted earlier? Yeah, so we came close, didn't quite hit it, and then up 5, right 2 gets me off my graph. So I've graphed my 2 lines correctly. We can actually see where they meet approximately, but using our skills from yesterday, we're not quite sure exactly where they meet. So it looks like around 4.5 and a little bit over 6 perhaps, but we don't know exactly where. Fortunately, we have a new method that can tell us exactly where our lines meet. So this is why we need this method too, guys, because in real life, unlike yesterday's task, every point of intersection was nice whole numbers. Real life isn't that way. We do need to be able to handle situations where our point of intersection does not have integer values. So let's give this a go. Let's use our skills from last week, and let's dive in here. So let's set our equations equal and solve. So I'm going to set 1. I might even just pop this over here. Set 1 equal to 2. So what are our equations? We have 1/2 x plus 4 is equal to 5/2 x minus 5. Now, another example where, yes, you could put these into decimals, and that's not wrong. And if ultimately that's what you need to do to feel comfortable, then you just have to do that. But it's not going to always give you an exact solution. I'm going to continue to use our strategy of clearing the fractions because for later grades and for other
scenarios in our course, we just need to be able to handle the fractions. But let's clear them out. Everything by 2. Why by 2? Because 2 is the only denominator. If there was different ones, we would find a common denominator. So what do we get? We get 2 times a half is 1. So we have 1x. 2 times 4 is 8. 2 times 5 divided by 2, that is exactly 5. And 2 times negative 5 is negative 10. So that does not look so bad. Let's solve this equation for x. And I might stretch you guys a little bit here. And I usually group my variable terms on the left-hand side. But for me, I recognize, hey, if I actually just subtract x from both sides and I work on the other side, I keep more of my numbers positive. So I think I'll stretch you guys a little bit. So we would get 4x and then minus 10. And then a little two-step equation. We'll add 10 to each side. Now, as a decimal, yes, you do get 4.5. I am going to walk through this question just using fractions. But at the end of the day, if you do need to use decimals just to kind of get by, like ultimately that's not the hugest deal in the world. But I mean, we do have to be able to handle fractions. So we get x equals 18 over 4, which is not wrong. Neither is 4.5. I'm going to leave that as a fraction in lowest terms. So ultimately, you guys have heard me say, I'm going to say this many more times this semester. Ultimately, if you have designs to take it through you calculus, you have to be comfortable working with fractions, comfortable putting things in lowest terms. But yeah, if you put in 4.5, it's not the end of the world. So yes, that is 4.5. And if we look at our graph, does 4.5 seem reasonable, guys, for a point of intersection? Compare the graph. It does, right? Seems like we're on the right track. Let's find the y value. I'm going to keep using fractions. If you want to just plug in 4.5, that will work too. Now, what equation here looks easiest to work with? Really, they both have a fraction in them. I'm going to put mine into equation 1. So I think x is equal to 9 over 2. So I'm going to put x equals 9 over 2 into equation 1. We're going to work with fractions for this one. It's not going to be fractions all the time, but I do need to give you guys a case or two where it happens just to prepare you. So what does that look like? So our equation was 1/2 offline mode. Go away. And we're back. Okay. Let's continue. So we have 1/2 times our x value of 9/2 and then plus 4. All right. So let's just work with fractions. We'll be okay. You guys learn how to multiply fractions in your earlier math grades. We're going to multiply the tops. We're going to multiply the bottoms. So that's 9 on top. That's 4 on the bottom. And then we have to do 9 over 4 plus 4. A little team talk here. If you have a scientific calculator, actually you have a fraction button, and your calculator will just do that for you and spit out an answer. For you guys using your phones, no such luck. You'll have to kind of follow along. But fractions don't have to intimidate us, guys. So 4 is like 4 over 1. You can write that as, we've talked about that. Any integer can be written as a fraction. And if you want to add fractions together, we do need a common denominator. Here, 4 is a good choice. So I'll multiply the top and bottom of this fraction by 4. I'm showing a ton of work here. This is 9 over 4 plus, that would be 16 over 4. And now I can add those. Ultimately, I get 25 over 4. I showed a ton of work there. 25 divided by 4 is 6.25, right? Which lines up with our sketch. We know we did it right. But as I said, guys, I do need to make sure that people moving on to the higher level courses, you're comfortable working with fractions. So I did want to mix